Welcome to Great Data Products. This is a live stream webinar podcast thing from Source Cooperative where we talk to data practitioners about their craft. We do this every month, and you can visit us at greatdataproducts.com to see previous episodes and find links to subscribe on YouTube or wherever you get your podcasts. If you follow Source Cooperative on LinkedIn, we notify people about it there also. And then we also have a Luma calendar where you can see that the next episode on greatdataproducts.com, but we actually have episodes scheduled out in January and February that you can see on Luma. I'll talk about that in a minute. But today we're joined by Matt Hanson from Element 84 and a good old friend, I would say. And we're going to talk about the SpatioTemporal Asset Catalog's specification. Matt, do you want to introduce yourself?
Yeah, thanks, Jed. Really happy to be here. Thanks for inviting me. Matt Hanson. I work at Element 84, and I have been, I'll give a brief background. I've been working in the remote sensing field for, close to 30 years now.
Wow.
And got into open source about 15 years ago, and I went to Phosphor-G and was instantly like, this is it. This is what I want to do. I started contributing to GeoNode, was my first open source project that I contributed to.
Nice.
And then I started working on other projects and then eventually got into STAC and standards.
All right. Nice. Well, I can say we've been lucky to have you in the community for a long time. Yeah, I mean, we've got a lot to talk about. You've done a lot, you've accomplished a lot, and I would say your involvement in STAC is really secured your legacy. I mean, among others, it's a community effort, which is partially what we're going to talk about here. So, you recently, let's actually back way up. And how do you describe STAC to people? And with the caveat that this podcast is not necessarily a geospatial podcast. So we do want to reach more people who don't necessarily have expertise in geospatial. So how do you describe STAC at a very high level?
Yeah, so STAC is, I describe STAC as a family of specifications as well as an open source ecosystem. And that's maybe not a really layman's way to describe it. So let's say that it's a simple, developer-friendly way to describe geospatial data so that people can actually find it and use it.
Okay.
That's the quick one-sentence version.
Okay. And so I'm going to play layperson. And I actually don't even have to pretend that much. I'm actually this naive in a lot of ways. I've heard Mark Korver, another esteemed colleague in this world, describe STAC as solving the problem of listing objects in S3. So, of course, I can't help but be very nerdy here, but part of the problem that we're facing, and it's not just in the geospatial community, it's in many other domains, is that we're dealing with so much data that even just listing the files that you have is expensive. It takes time. And so you can imagine having a corpus of millions and millions of satellite images, and you have to, go through that haystack to find stuff. One way to characterize STAC is that it helps it make it basically easier to index all that stuff to find what you want. Is that fair to say?
Yeah, I think that's definitely fair to say. I mean, the tying it to S3, it's not necessarily required, right? STAC could describe data files wherever. It doesn't have to be in object storage. But no, I think that's a good way to talk about it. When I give a STAC presentation for new folks, like a STAC 101, I often will talk about exactly this issue of the explosion of geospatial data. There's been so much data, and if you look at just NASA's holdings and their projected holdings over the next 5 years, we see so much data that if you don't index the data, I had this saying that if your data is not indexed, it might as well not exist. Because if nobody can find the data, and it's just as you say, you're just getting a listing of all the files, how can you actually find the data that you want if there's a billion files in object storage, let's say? And that's not far-fetched. That number's not all that far-fetched.
No, yeah, not at all.
Yeah.
Oh, go ahead.
No, I was just saying, if we look at Sentinel-2, right? Like if you look at the entire Sentinel-2 archive, there's 25 million files. There's 20 files for each.
Yeah.
There's 25 million like scenes, and for each scene, there's like 20 files. So it starts adding up really quickly.
Okay. And then when you say easy, easy for who? So like what, STAC stores its data in JSON. So who's like your typical user of STAC? Like what kind of software do they use? Like what kind of job title do they usually have?
Yeah. So, geez, that's a good question. I think that the ultimate data user is probably a data scientist.
Yeah.
Like that's I think that's who the original target was. When we first started looking at this, we were primarily looking at public data sets because that's what is available. And, that's what we were looking to index was NAPE and Landsat and Sentinel-2. And it was really a data science user problem. And that was my background. That was where I come from, was working with scientists and working with different types of data and having to use different formats and different tooling just in order to find and access the data. And so I think that really was the primary user. We talk about it being developer friendly because of the open source ecosystem. But that's really developers working in tandem with data scientists in order to leverage and use the data.
Great. Yeah. I mean, and so I'm leading you here a little bit to the point being that like, I think, I've worked in the open data space for my entire career, basically at this point. And so many conversations have revolved around like making data easy for anyone or something like that. And I argue that hasn't worked out super well. You actually need to find like who are the actual practitioners that are going to use the data and like what will they be comfortable with, or like what will actually help them, rather than having a kind of nebulous like everyone thing.
It's clearly not everyone, but I mean, we have had like journalists, like people have reached out to us from like New York Times, and like they're creating stories and they want to access geospatial data, and so they've used some of the tooling around that. So that's as close to a layperson I think that we've really worked with. Is from journalists who want to tell a story, and they just want to find data. They just want like data from 5 years ago and today to look at a change over time and use it to write a story about. And they were able to use the tooling like PyStack client, or even before that there was Sat Search, was an earlier tool set, and they were able to figure that out, but they were still leveraging developers to do that.
Right. Well, but I think then, but there's another clue here, which is that you have, we'll go on this with journalists. You have an audience that typically has not been able to engage with imagery or like, geospatial data. But they are, we've watched this happen throughout our lives, like becoming more savvy and more aware of the need to be able to like use software and data to tell stories and things like that. But they're coming to us from like a completely different place than I think most geospatial data practitioners were in previously. And so the key there, I mean, you mentioned PyStack, like they're, for whatever reason, a lot of journalists use Python,
Right.
There are different communities that use different tools. Yeah.
Sure. Yeah. Language of data science. Yeah.
Yeah. Okay. We actually already have a question on YouTube from who I'm just gonna call Sig. I'm not sure if that's his or her name. I can't tell. But asking, STAC is built around sharing data easily to anyone. Let's say you want to use to share more secret data with access control, SSO, encryption, etc., and different users that have different access to different data sets. I have some thoughts on this, but like as you mentioned, like STAC doesn't have to be explicitly tied to a cloud object store or a public bucket. Do you want to take that? I imagine you have some.
Yeah.
Some
So this
actual
question
examples
comes
here.
up. Yeah, this question comes up a lot,
Yeah.
right? Because like out of the box. So I will get a little bit more technical here, but
Sure.
what we use. So we have an API called Earth Search that indexes public data sets on AWS, and that's an implementation of STAC API. And for example, that implementation has no authentication in it because we were using it originally to index public data, and so we
Right.
didn't have need for controlling access, and all the data was public, and so hadn't added that in. So we get that question a lot. And Stack Fast API is another implementation that didn't have like really core built-in authentication at the time that it was first created. So there's a couple ways to do this. I'll jump to the end first, which is that there's a more modern solution for this. It's called Stack Auth Proxy that DevSeed has created, and that can be used to control access to individual items and collections based on attributes in the data. So that works pretty well. But what we've generally done is use it as a proxy. So you have your catalog, and that's open, or it's behind a firewall, but it's like available to anyone who can access it. And then we have a proxy in front of that handles the authentication, queries the catalog. It knows what people can see, and then returns that result. So it's going through the proxy, but these tend to be all one-off solutions that are created. And so I think Stack Auth Proxy, if you haven't seen that, that's definitely something to look at that you can combine with Stack Fast API or potentially any Stack API implementation.
Okay. So yeah, I mean, I think one thing I'll like underscore here also is that like Stack is a metadata spec. It itself doesn't say anything about authentication or anything like that. Like, so
right.
it's been built to be very flexible, useful in all sorts of environments, and extensible. I want to just stay in the weeds of Stack a little bit longer. So the specification is made up of other specifications. So you have the idea of I'm going to go in order of like collection, catalog, and item. Can you walk through each of those and like what they encompass?
Yeah, sure thing.
Sure.
So, so we start up at the top. That's a catalog. A catalog is really just a container. It's a JSON. It contains really simple fields, like you have a name, you got a title, you have a description, and then you have, most importantly, all of these entities within Stack have links. And links are probably the most important part of Stack, right? Because when we got into this at the beginning, the ability to crawl a catalog was really important because that's the way the internet works, right? Is by crawling things. And so we wanted to be able to link a whole catalog together and link down to items and link back up so that you could really visit any part of data in this catalog and be able to crawl it in both ways. So catalog is the starting point. In an API, especially, the catalog that's your landing page, and it's going to contain links, and it will contain links to the collections underneath it. And each collection looks a lot like a catalog. A collection,
right?
At one point, it even was a catalog. It was derived from a catalog. Technically, that's actually not the case anymore. It's its own entity, but it looks a lot like a catalog. But collections are ways to group together items and data that is similar to each other. And so the most obvious case is when we look at the big public data sets. We see Sentinel-2 or Landsat, and like Sentinel-2 level 2 data, that is a collection, right? It contains a bunch of items, and that's your next level down is an item. And an item is this is where we move from JSON to GeoJSON, because an item actually represents a specific location and a specific time or range of times. And that's really where your data is. So you can think of it as a scene. You can think of it as it's a footprint containing data. The data is contained in what are called assets. So that's really the fourth entity type, except assets are actually embedded directly in the GeoJSON of items. So you have the catalog, collections, and then items. And so that's the general hierarchy. And we have links that allow you to go all the way down from catalogs to items. Now, there is some nuances between a static catalog, what we call a static catalog, which is really just a bunch of linked JSON files on disk or on blob, in an object store. And that's an important distinction between that and a dynamic catalog, or what we call an API. So there's some nuances, because you can have, for instance, sub catalogs within a static catalog. If that's confusing, or it might be a little confusing or not, but it's a way to like partition the data, basically. So you can use sub catalogs to organize it. So you might have a collection, and then underneath that, we'll have like a catalog for each continent, and then you go under the continent, and then that's where your items are. So it's just a way to partition and organize the data. In an API, this question comes up a lot, which is why I have the whole narrative around it here. But like in an API, you don't need those subcatalogs, because you don't need to partition the data, because you can search for the data on what continent it's in, or what path row it is, if it's gridded data, or you can essentially partition on the fly anything you want. So that's the important distinction between static catalogs and an API. We get the question a lot. People have static catalogs, and they ask, how can I search this? And you can't really search it. You have to index it first. Like there's that missing piece. But STAC originally, Chris Holmes really wanted us to focus on being able to have static catalogs, because not everybody wants to stand up a server and incur the cost of that. And they just want to make data available, and they want to share it with people. And so the easiest way to do that is just have the metadata on disk. And it's all linked to each other, so you can crawl it and index it if you wanted to do that.
That's right. Yeah, I mean, I can speak to this. I mean, I think like this is a long time ago now, like when all this stuff happened. So when and it's relevant actually to another comment or question from Sig on YouTube asking, did the chicken or egg come first, i.e. the STAC or the S3 and the cloud optimized formats? I assume STAC wouldn't exist with only old files on disk. So there's a lot to respond to there. First, I'll say this is a fundamental issue about sort of the distinction between file storage and object storage that is like just not obvious to most people, because they never have to think about it. Is that like, if you're using a file system, like if you're using a computer like a laptop, or normal computer with a GUI and stuff like that, you probably are interacting with a file system. Your computer needs to have an understanding of like what are the files on your hard drive, and has an index of them. It also has an index of like how the directories are nested and things like that. And you can search your computer for files and stuff like that. Otherwise, a lot of applications would be a huge pain to use if you didn't have that index. Object storage like S3 has nothing like that. So object storage is just like, you have a file, you give it a key name, and you put it in a cloud, and it's there. If you know that key name, you can get it back out. And so this is the issue, going back to the discussion before about like too much data. You can imagine a scenario where you have so many objects, you have so many files you're dealing with, that even the index of them would be too large for your laptop. Like just listing the names of the files would be too large for like a lot of people's local storage. Like this is not a crazy idea, let alone like metadata about all those sorts of things. And so STAC and a lot of sort of cloud optimized approaches are an attempt at standardizing or finding patterns whereby we can break up all of this content into ways that are manageable. And that has to do with things like STAC catalog, as you described, Matt, like with all these JSON files pointing the way, and also things like naming conventions for things and stuff like that, that like all add up to make that stuff work. The only other thing I'll say is that, you know, when we brought Landsat onto AWS, the metadata that USGS would provide in its tar balls with the imagery was just this like weird text file that was like space delimited or something like that.
MTL
Do you remember these?
file. Yeah.
Yeah, the MTL files, right?
Yeah.
And so we set up, I didn't, you know, I was just like, you know, I think it would be better at least if this was in JSON. And so what we did is we created a process that was happened at the end of every image that we brought in and turned into a cog. As soon as it all landed in the bucket, we would run a Lambda function to take that MTL file and turn it into a JSON version of it. And I think that was kind of the kernel of like the sort of the first notion of doing something like this, where it's like, you should be able to get to an image and you should have a reliable little machine readable, you know, or like easily parsable bit of metadata that you can find right by it.
Yeah.
And then I guess, and then also just to close this off, also with the understanding that, yeah, there are a lot of people that are never going to run their own API. Right. They can't stand up a service. And there are a lot of data products out there that do just need to land somewhere. And if somebody else wants to index them, they can. And I think the static STAC catalogs make that easier, I would say.
Yeah. Exactly. Yeah.
Okay. So now let's talk about the blog posts that you wrote, like the sort of the history of STAC. Give us the high level overview. I mean, we included the link to it in as we've promoted this and stuff like this. I'll have to put it back in the chats and stuff like that, but it's really good. But summarize it quick. Okay. It's a comprehensive post, but like, tell the story again.
Okay. So yeah, it is a bit lengthy. So yeah, so I did these two blog posts. The first one I wrote a couple years ago, and I always meant to write a part two, and 2 years passed.
Yeah.
And then I'm like, you know what? I've long been wanting to do it. I had draft and various conditions. So finally I'm like, this is the time. You know, STAC was just as we were publishing it, STAC was just accepted as a community standard for OGC. So it seemed like a good time to actually publish it. So the most recent post is called "Why STAC Was Successful," and it really looks at like how on earth did this effort that started back in 2017 with 20 people in a small room at the Marriott in Boulder, how did this turn into something that is now being adopted by commercial companies that are launching satellites as well as space agencies? So NASA, USGS for the Landsat program was definitely an early adopter that helped a lot. So, so I talk about this idea of guerrilla standards, and I gave a tip to Howard Butler on that because I love the term guerrilla standards because it really encapsulates what this process is and how it's different than traditional standards work. So that's a big part of it, and we could talk more about the guerrilla standards. But it's this grassroots approach where you get people that are interested, you get stakeholders that are interested in doing something better and working within a community rather than making a bespoke thing on their own. And you build something that like will serve everybody's needs, and this is, I think this is critical because I'll skip to the end a little bit again here and say that the conclusion of this is that there's really, when we talk about standards, there's really only one metric. Well, I say there's three metrics that matter as a bit of a joke, which is adoption, adoption. And that's true. Like you can have the most elegant standard that could exist. You could spend lots of time and make sure, and this covers every possibility, and it's very elegant and very nice, but it doesn't get used. And so that's not a success story at all. You can have something that's maybe a little crappy, and if everybody uses it, it's hard to argue that like the crappiness was a bad thing. If everybody's using it, it's improving everybody's lives, and it's making interoperability easier. And so the central thesis of the post was that adoption is the only thing that matters, and then it examined like how did we drive that adoption, like how did we ultimately, like that's the question, right? Is like it was successful because it's been apparently adopted pretty widely. And so what was it that we did that drove that adoption? And part of that is the guerrilla standards approach of getting stakeholders and getting champions and getting people excited about it and having buy-in from people. That's an important piece of this, is that when people are part of a process, they're more likely to use it. Their concerns and their needs are being listened to, and they're more likely to go back and champion it and use it internally for their own projects as well. And then another aspect is the simplicity of it, the core spec. This wasn't about trying to make a standard for everybody and everything. This was about creating a spec that was going to meet 80% of the needs, and really focus on what those needs were. Like, how do we find data? How do we have consistent metadata across different providers? How do we have something really simple? And how do we encourage people to use it? We encourage people to use it by creating an ecosystem of tooling so that there's a low barrier to entry. And so the ecosystem is a big part of the Guerrilla Standards approach, is that you need to start building implementations. And at that first sprint back in Boulder, at the end of the day, thanks to Rob Emanuel and Seth Fitzsimmons, we had a server working at the end of one day that was serving up NAPE data. I don't think if we went back to it, it doesn't really resemble much of what STAC looks like today, but that wasn't the point. The point was that we got some ideas together, we stood it up, and it worked, and then we could continue to iterate on it. So, so let's see, what other aspect of the post that I feel like I should call out. The community collaboration is critical, like having in-person sprints that are open for anybody to join. That is key as well. And I would be remiss if I didn't mention the timing. The timing, I think this was just serendipity perhaps, but the timing of STAC was critical to its success. We were at a point where the public clouds were maturing to a point where, like, geospatial, we were starting to see more geospatial data on it. Like, you were just talking about your effort on bringing the Landsat to AWS. COGS were really starting to gain traction. There was lots of launches, an explosion of private companies launching satellites. And so there was just a real need there. Like the previous methods weren't working. And so there was a real need in this, and no one else was really solving that. And so, it just filled a missing layer at exactly the right time.
No, it's great. I mean, it's, such a fascinating example of really what we're actually trying to do with this live stream webinar podcast thing, which is like, we know some things have worked. Like, we need to understand, like, why did they work? Like, what made the difference? And like, it's so easy to look back at. I mean, it's very easy to look back at failed attempts at foisting standards on the world. So many standards that have not been adopted at all, right? Despite all the good intentions and the need and things like that. And so it is it feels mysterious why STAC was successful, but I think your post and everything you just said makes the case. It's not a mystery here. Like, I think we can probably look back at things that made it successful, and it's actually kind of interesting timing. We got another comment on YouTube from I don't know, this username is Bent Quarter, so Bent Quarter. Who knows? But asking, is there a GUI for building a stack? Which is super interesting question, because everything you're talking about, you talk about, like, we got all these people together and it was easy for them. And, we had a server running by the end of the day. It's like the people that we're talking about are data practitioners. It's a pretty esoteric, like, cool kids club that, these sprints, they're not huge. It's a small group of people who really have practical experience and needs and they understand each other, and which has allowed that, I'd say, like, allowed you to gain traction really, really quickly. But yeah, we are at the point, I think, like, this question, like, is there a GUI for creating a stack? Like, that's an interesting question. Like, certainly wasn't the priority, but where are we now?
Yeah, it is an interesting question. So the answer is no. Like, there isn't, right? There's interfaces for browsing catalogs. There's Stack Browser. We have a user interface that we stand up for Earth Search called FilmDrop UI that is an interface for Stack API. There's others out there as well. Microsoft Planetary Computer has the user interface. But yeah, these are all kind of focused on being able to search and browse existing APIs, not actually creating your own. And I think that's just because those are different user bases. Like, the people building the Stack metadata are generally developers, and you have a bunch of data, and you need to you want to generally programmatically create the metadata from it. So, like, extracting the footprint of it, or pulling metadata fields that are important from the original metadata or from the headers from the data file. So that really is done in a programmatic way. I think somebody might have created a user interface for creating collections. But it would just be a form field where you can go in and fill things out. But it's not a bad idea either, like, having some sort of user interface to make this easier. But I think it would have to be combined with some back end that is where maybe you're dragging and dropping a series of files, and then it's going to try and fill stuff in, but then gives the user an option to be able to add in additional details, and then extend that to ingesting a bunch of other scenes from it. Like, maybe there's something there that actually, could be useful and make it easier for users to make their own. There's some tooling for the CLI for creating Stack. Like, there's Rio Stack, which can be used to create a bare bones stack item from cogs. But no one's actually really brought up a GUI for building a stack. Yeah,
that's an interesting question. But it also gets at, like, I think, like, sort of the challenge that I think, boy, it's a huge challenge. It's a challenge that, like, a lot of government executives need to understand. A lot of people working in policy, people working on workforce development, people educating future leaders and data scientists, is that, like, the volume of data that we're working with is so large that, like, the notion of distilling or creating tools that are really designed for, like, humans to, like, click and drag and point at things and track with your eyes, like, to do stuff, that's not how it's going to be done.
Right. It has to be programmatic. And so that's why I said, like a GUI that allows you to maybe set that up, right? Like, set up the programmatic creation of it. Like, that might be useful, but you're right. Like, you're not gonna manually create a stack for every scene. For every item or image.
Yeah. I mean, and that's, like, this is not to to dismiss the idea, like, again, like, should there be a GUI, or, like, why this is it remains an interesting question, but I think it reveals the fact that like STAC emerged because we were suddenly found ourselves dealing with so much data that it required a sort of purely programmatic approach at first.
And those were the first use cases too, right? Like,
right.
Was lands. It was these big archives. It was the Landsat, Sentinel, it was NAPE, and it wasn't like small amounts of like commercial imagery because we didn't have access to those. That cost money. So this was the primary use case was how can we make it easier for users to access public data sets?
Right. I'm imagining now like a use case where, like an entirely local use case where it's like, okay, as I mentioned to Matt before we started streaming, there's a mudslide in my neighborhood in Ballard. I don't know any details about it. I hope no one's hurt or anything like that. But literally right now, there's a mudslide in my neighborhood. But you could imagine somebody going out there like with a laptop, a drone, flying some imagery, producing a relatively small product, and wanting to package that up in a nice, tidy STAC catalog that they can then get out somehow. And that's like kind of like, I could see that as being a very sort of like layperson, not touching the cloud, kind of Dropbox scale type thing, that you could do. And that's a maybe use cases like an emergency response type thing.
Yeah, for sure. Yeah, that would be. And some people I think have created STAC catalogs for small data sets like that. But then that raises the next question, which is, well, how do people find the catalogs?
Well, I mean, I want Source Cooperative to be a place where people find these things.
Right. So there's
brought to you by Source Cooperative. This is our podcast, so I get to do stuff like that.
Yeah, that was a lead-in for you to play.
Thank you. Well, thank you. Yeah, actually, I'll do that is actually a prompt to do what I said I was going to do. We're going to do housekeeping really quickly, and just because we know that some people have joined midstream. So this is Great Data Products. It is a live stream webinar podcast thing brought to you by Source Cooperative, which is a data publishing utility that we manage. You can go to source.coop to learn about it. But this is the time where we talk to data practitioners about their craft. And this month we're talking to Matt Hanson about the SpatioTemporal Asset Catalogs, or STAC, metadata specification, which has been wildly successful. And then I'll do a little bit more self-promotion on this. We wrote, so there's this is Great Data Products, the live stream webinar podcast thing. We also wrote a blog post or published a blog post a little bit ago called Great Data Products that has, I would say it's done pretty well. You can go to radiant.earth/great and read that. And I'm going to share something. Let's see. I don't know if I can do this. Can I share my screen? I'm going to share a window in response to, again, back to the question about GOIs. And so this is a drum I've been beating for a really long time. This is a graph I've been talking about for forever, many years, but it's been enshrined in this blog post, and I'm going to like expound on this in a future post, but like it's useful to understand, or sort of to think about, how do you maximize the usability of data, and like why a programmatically accessible approach is so important. So if you have raw data off of a sensor, it is not going to be that useful to that many people. Like there's a cost, just like an inherent cost required to like extract any sort of value from it. And satellite imagery is sort of like notoriously difficult here, which we can talk about all the reasons why that is. And so, but what often gets funded is like, I want a thing that's going to track mudslide risk, for example, in the Pacific Northwest, right? And so you can spend a lot of money sorting through the data, processing it, creating an interface, doing user testing to create a tool that helps you understand mudslide risk in the Pacific Northwest. You've gone over this huge arc where you spend a ton of money, but then the potential value of the data is then diminished again, right? And so this is always kind of like my warning against focusing on GUIs or dashboards and stuff like that, is that by creating an interface like this, you're making a ton of decisions about like what the value of the data is. And like, instead, what we should be trying to do is like, how do we maximize the queryability of the data? And sort of like, it's this, again, I call this the sweet spot graph. We have to find this place where it's like, we're taking out a lot of the annoying, undifferentiated heavy lifting required to like get the data in a way that's queryable without over determining it. And so, anyway, I'm preaching to the choir with you, Matt, but I just
no, you know what a great example of that is too is Landsat.
Please.
Like, let's take a look at Landsat. There are 2 processing streams that Landsat does. They have an ARD process, which is in one projection. It's actually in a Albers projection. There's 5 different Albers, maybe 7 Albers projections, depending on the continent.
What's your favorite?
Favorite continent, favorite Albers projection?
Yeah.
I don't know.
I'm sorry. Just go on. I'm trolling you. Sorry.
So there's the ARD stream, and like, so that's distributed as these ARD tiles, and then there's the regular stream of data, which delivers UTM tiles. So the question is like, why these 2 different things, right? And the reason why is because people like and are used to UTM because it's a nice, pretty picture, but it introduces more errors than the Albers projection does. The Albers projection minimizes the distortion errors from the original raw data. And so I have this thing that I like to use, which is as soon as you pick a projection, it's the wrong one. And so this is the graph, right? Because it's like, you want to maximize value, right? Then you should try and avoid making assumptions about how people are going to use that data. And projection is a perfect example. Like, rather than picking a projection that you think is going to be useful for everybody, just what's the one that's going to minimize the potential errors, because that people are going to reproject it. MODIS does this great. MODIS does a sinusoidal projection, which is the best projection for minimizing distortions due to the orbit of the craft. Everybody hates it because it doesn't make for very pretty pictures. If you open it up and just look at that directly in QGIS, like, it looks all wonky, but it really is. It really is the best choice for that spacecraft.
Fascinating. Oh, wow. Okay. You know your stuff. Which
I know a couple of things, and I just keep on using the same stuff.
No, it's great though. Well, we have a pretty interesting question about this though, like on this note of like, what is the right way to present data, from the great Max Lenormand, who I'll just embarrass him a little bit more. Like, there's no way we'd even be having this podcast if it wasn't for Minds Behind Maps and the approach that he took with that. So he asked, is this still does this still hold in a world where it's so much easier to make custom dashboards, GUIs, front ends with AI? I have a response to that, but I'm curious to hear what you think. Since, especially about, you have Element 84 does so much great work producing really interesting tools. And what are your thoughts on this?
Well, I like UIs. They're pretty, but they're also pretty impractical, aren't they? Like, if we look at the data, 99.99% of the data out there, right, no one's ever going to look at.
Right.
And so I do think we spend an inordinate amount of time focusing on visualizing remote sensing data when that's actually not really a great use case. Outside of demos and outside of pretty pictures, maybe, journalists like that, if you're telling a story. And so, it's great that it's easy to make custom dashboards. And I've been working on some UI stuff recently, and it's fun. But I think from a practical standpoint, we need to be focusing more on unlocking the value in the data with programmatic backends.
Yeah.
I don't know if that really answers the question though. Like,
well, I think I agree with you. I think UIs are maybe the wrong thing to be thinking about. So I agree with you on that in the sense that like I use this example all the time. I may have already mentioned it on this podcast. I probably will again in the future of like so many like attempts at making Earth observation data useful for like agriculture, especially in like low and middle income countries where it's like, no, it's great. We're going to give the farmers an app and then they'll know what to do. And I'm like, no one's going to use your app. Like you're not, the farmer's not going to install your app. They're not going to open it. It's not going to become a part of their life. Like it's possible. Like there are sticky technologies that people do, become part of people's lives, but like it is so expensive to make that happen. And it's so rare for it to actually happen. My theoretical, hypothetical, like Earth observation application for the farmer in a poor country is suddenly they can get insurance for some reason. They don't know why, but like there's a flyer for them to get insurance, or a salesperson comes and visits them and is like, hey, we can actually sell you affordable insurance now. The basis of that insurance product is Earth observation data that allows for that insurance product to exist. It is a product of data, but the farmer doesn't have to know anything about that. The value of it gets built into the price of the insurance, and like that's how the value is delivered. Is there a GUI or some sort of UI to the data between the receipt of the data and the creation of that insurance product? Like maybe not, but like I think increasingly. So partially to answer Max's question, like in the age of AI, and I know Matt, you've said stuff about this before, like it's just going to be a model doing all the analysis, and what's derived out of it is going to be like some sort of index or figure that gets put into a spreadsheet or a database, or perform some
tabular
other
data.
Yeah,
the future is tabular data.
Yes, which by the way, you can preview CSVs on Source Cooperative now, which is amazing.
Nice, great.
Yeah.
So, all right. So this is a bit of a tangent, but like I feel like it's maybe a good time to say this.
Yeah.
And I used to give a presentation and I'd talk about this a little bit, and I don't know, this is going to seem like a tangent, but
go for it. That's why we're here.
You talked about the farmer, and getting the app, and there's another reason why that doesn't really work, and it's because remote sensing sucks. All right, RSS, remote sensing sucks. And what I mean by that is that, like, I've been in this space for a while, right? And if you look at old research papers, new research papers, and like take a look at land cover products, for instance, you can get land cover products from different producers for the same year using the same data, and like they might be 20-30% off, 20-30% disagreement with each other, because there's a lot of stuff that goes into the image that's formed. The entire big equation, the radiative transfer equation for how that light propagates and gets the image, means a lot of variability. And when we talk about level 2 data, we have atmospheric correction, which also includes a tremendous amount of variability. And so I have this, issue with the ag community, because I feel like, and lots of other, I think industries have done this as well, where they've overpromised and they've under-delivered what remote sensing can do. And 20-30% errors are not uncommon. But if you go to an engineer that is doing space exploration, right, or any other engineering discipline, you're like, oh, 30% errors are normal, they're gonna laugh at you, right? We didn't send people to the moon with 30% errors, right? Like you're gonna miss the moon. So so I think there's an aspect here of like having realistic expectations around what remote sensing is capable of. And traditionally, back before Landsat was available on S3, the people doing that work were scientists. And so I don't think it didn't really come up that people were like misusing remote sensing data in a bad way. But once that Landsat data became available to the masses, and this kind of ties in some of the stuff you were saying before, everybody started using this data. Like a lot, like companies were, like startup companies were starting to leverage this to generate NDVI. I remember working with one company back using that Landsat data to calculate NDVI. And the problem was, and I think I've told you this before, Jed, is that
Yeah.
data was not appropriate for doing that, right? Like the original Landsat data that was on AWS was level 1 data. It wasn't even level 1 top of the atmosphere data. It was like top of the atmosphere prime. So it wasn't even accounted for sun angles. And so that just like, I think that ended up causing more of the same problem. Like people continually, being overpromised what remote sensing can do. And so that's my issue with the ag community, is that I feel like they've overpromised what is capable, what it's capable of. Remote sensing is very powerful because I might not be able to measure that water quality in a lake very well, with just some sort of air, but I can look at every lake in the world, right, every day. And what it's really, really good at is looking at relative differences. So time series is where remote sensing really shines, being able to look at change over time, and differences. And then this leads into a whole nother segue of, this is why most commercial satellite data providers have bad business models.
Okay. We should keep going down this path.
I think that like they're focused on this idea of selling imagery, right? Like scene by scene.
That's right.
And there's really limited use of that. Like maybe for photogrammatists, like, looking at it.
That's right.
That's how we originally use it. We have a high resolution image and we're going to look at it and identify things. But the real value in all of these archives of data is the time dimension of it. And so I don't know. I hope for a future where those archives are maybe unlocked. Maybe there's a subscription model where you can access the whole thing, the whole entire archive. But like this whole piecemeal, like by image just seems it seems a little ridiculous.
Absolutely. Okay. I mean, this is
there's
sorry. Yeah. I mean, we're tipping into the philosophical, which is great. We get to do this. Is like, I like to say, like, imagery is a metaphor for the data. Like, it's like, like imagery is like one way to see the data because you want to see it, right? Like, I went through this a bunch when I was at AWS, building the open data program. Is that I'd have executives that are like, where do I see the pictures? Like, what will it look like? And I'm like, well, do you know what an S3 bucket looks like? Like, it's just like, it's a bunch of objects, with names. Like, it doesn't look like much. We had the same issue when we started hosting Hubble Space Telescope data, where people are like, I want to see pictures of like the galaxies and stuff. And I'm like, yeah, that would be cool. Like, that's not what's in here. Like, this is like this is telescope data in a weird format called FITS that has its own, great, wonderful people trying to figure out how to cloud optimize it. But it's like, the imagery is a derived product that's made for a human to look at with human eyes. That's just one tiny sliver, like one tiny slice of like how this data can be interpreted or used. So, I feel like I do feel like I want to defend myself with the Landsat stuff. First of all, I'll just say, like, I didn't know what I was doing. Like, I was just like, well, look, we're going to bring the Landsat data on AWS. I had some ideas bandied about with Peter Becker from Esri and Frank Warmerdam at Planet. Specifically, like, I consider them like the two people that were like, you should do this internal tiling and overview thing that ultimately became the known as the COG. And that was it. But I was just like, well, we'll just see what happens. But I guess my question though is like, is that a solvable problem? Like, is any data fit for, safe for public use and distribution?
Probably not. I mean,
right?
I
don't think so.
Every data can always be misused. And don't get me wrong, right? Like that move of Landsat to the cloud was huge. It was really popularized Landsat. We wouldn't be where we were today if that data set, that very important data set, wasn't there. But the time was that, like, that data wasn't available really well, it was available to people, but like that's not who was using it, right? It was scientists, and it required that anybody using it probably should have opened up the Landsat data user handbook and read like what the data was and what needed to be done for it in order to do things like compare NDVI over 2 different days. Because couldn't do that. But people did it anyway. And so, but like I could point to other data. I'm sure that that's, that happens all over the place. So, education, right, is a good thing. Relying on experts, like, these are things that companies need to do is value that expertise in the geospatial and remote sensing domains. And not just assume that because data is easily accessible, and you can just easily find it, that like you can do things without really knowing what you're doing.
Right. Well, yeah. I mean, I think I would just I advocate for sort of permanent, constant vigilance and skepticism around everything. I mean, the history of the internet so far, which was designed explicitly to like improve the sharing of like research data. I mean, that was Tim Berners-Lee's like goal, was like, I want to be able to share stuff with my colleagues more easily. We're sort of epistemologically like, so it's very hard to say whether or not we're better off, because yes, there's a lot more information out there. I would assume a lot of it is accurate and great and pristine in a lot of ways, but like there's really never anything stopping anybody from twisting it, interpreting it, turning it into a narrative that, fits whatever their agenda is.
Yeah.
Let me go to the comments again. Sig asked about WMS and how it made easy to get many large raster image, I'll just put it on the stream here. To get imagery into legacy desktop and web apps, might STAC be implemented in a similar fashion? It has been. I mean, Esri has supported STAC for a super long time. Do you have comments on that?
Yeah, no, yeah, STAC. There's a new QGIS feature. There's a STAC plugin that actually works really fantastic. So yeah, I think that's already happening.
It is happening. And then from CJ Levinson, I'm curious to hear how this conversation extends to model data sets as opposed to remote sense data, and how this relates to my point, Jed's point, of good data products being about making less decisions. So yeah, thinking about climate models, weather models, mostly modeling outputs, which would be the main geospatial artifacts. So yeah, I mean, Element 84 has done some great thinking on embeddings data products and things like that. I think that's relevant here. What's your thought on this, Matt?
Yeah, well, there's a couple of aspects here, right? There's the aspect of like how these model data sets, like these generally large homogeneous model data sets, fit into STAC, but I'm not sure that's the question. Is that
no? Yeah, less about STAC, but just more, I think, about how we're talking about like, data that's fit to be shared and fit to be used. And now we're dealing with like data products that are just model outputs. So like a model's done a bunch of magic on them.
Yeah, so I think that gets into your curve, right? Which is like what where on the curve is that modeled output? But like generally speaking, I think that like that's generally what we want, right? Like this is what users want, is they want the modeled output. They don't want level 2 Landsat data. They don't even want level 3. They want, what they want is they want planet variables. Like Planet Lab variables data set is exactly the type of thing that we need to see more of, I think, where like this isn't imagery, this isn't time series. This is like I'm looking for a particular type of data, a variable, and I can get that, and it's been derived from imagery, but it's gone through a process that weeds out all those edge cases and everything. I think planetary variables are that's a great data product right there.
Yeah. I would also say, so this is a shout out for the time to shout out Dynamical. So the Dynamical podcast, which is called Weathering, which is just a an absolute delight. This is from the people who build upstream tech. But anyway, they have this great podcast where they'll actually read papers on, weather forecasting and advances in weather forecasting. And in a recent episode, if I let me see if I can remember which one it was, but it was I think it's the one on, that's the most recent one, a taxonomy of bias, sense making, heretical physics, and the Tom Hanks, Bill Murray multiverse. It's a good episode, but where I think they discuss how, like, we already interact with a lot of models and develop opinions of them over time based on their usefulness, right? So, like you were saying before, like a lot of satellite imagery has these like insane, error rates or whatever. They just have like substantial error rates, right?
Mm-hmm.
They still might be useful. There's this, the adage that like all models are wrong, but some are useful. And so, I would say, I guess I'm just going to agree with you to say, like, this is what we want, are to have models that are able to distill data into things like planetary variables, or like basically things that can support decision making. And I think people aren't idiots, like they'll figure out, like, is this useful to me or not? And it's possible that sometimes the model gives you something that's like catastrophically bad and like you lose money on it.
Right.
And you'll be able to make a decision whether or not you want to trust that model again. It's is the way the world works. Like, I think it's so easy to think about, like, or just it's so easy to like overthink this sort of stuff. Oh man, I've missed out on LinkedIn. People have been saying stuff.
So while you before you do that, have I told you about my Star Trek theory of remote sensing?
I love this. No,
okay. Well, we're on a podcast, so obviously I have to now explain it anyway. even if you had said yes, I've heard this before.
Yeah.
So if we look at Star Trek, right, like my whole vision of the future, I hope is way more Star Trek than a more dystopian version. But in Star Trek, you have tricorders, right, and you have sensors. And what do those sensors not do? They're not sending back images that are then analyzed, right? You're scanning for life, you're scanning for a particular element, you're scanning for specific variables. And I think that maybe there's an aspect here, like we're creating general purpose satellites. Historically, Landsat, right? It's like, well, we don't really know. This could be used for a bunch of different things. But we're increasingly, I think, seeing companies that are coming up and creating satellites for particular specific verticals. They're selling the satellites. It's satellite as a service. And I think ultimately, maybe that's where remote sensing goes, where there isn't a satellite that's like taking an image and then we're downlinking that and then like figuring out a bunch of different use cases and using it for a bunch of different use cases. But rather it's like, no, this is like, what you see this with GHGSat, right? It's like, no, this is a satellite for detecting methane. Like, it's a single purpose thing. It's the Star Trek sensor. It's like scan for life. It's like that might actually be an optical satellite, or it's a SAR or something like that, but it's doing something, and doing something on board, and then just sending back just the thing that you're interested in.
Yeah. Okay. Sorry. Now I've got it. This is great. Go Star Trek. It's funny. I'm not a Trekkie by any means. I did watch The Next Generation a bit when I was a kid. Really liked it. But I brought Star Trek up at some recent open data event that I was at, as just being like, because people are like, are there any examples of like literature or stories about like the future of like technology where like things are good? And I'm like, I think Star Trek is like one of those. Because we're just so steeped, and we have been for many years, into kind of like dystopian technological stories and stuff like that. And I think we should keep Star Trek in mind as like a vision of where we could take things.
Yeah.
You reminded me though. So last week, a bunch of our friends were at a National Academies of Science workshop on Earth observation and the future of data stewardship. And I pitched basically what you just said in a way. I mean, we worked within groups to come up with a 20-year strategy, and I had some license to kind of steer the Ouija board, as I would say. Like we're all hacking on these ideas, but this really wasn't my idea because it really did come out of the group. It was just sort of this realization that like I think we know a few things that we want to accomplish, like in terms of like governance and let's say like environmental management or something like that. And rather than looking at the next 20 years of Earth observations and thinking like, well, what sensors do we need? And what file format should they be in? And what should the standards be? And like, who should pay for it? And it's like, but what I led with when I was sort of reading out from the group, like, I think if we're thinking 20 years ahead, we should assume there will be more sensors. There are going to be more data products. There are going to be more models producing all sorts of stuff, more users doing weird things that we could have never anticipated. And what we should probably do, and I cannot emphasize how hard this was for me to say out loud, we should maybe look at something like the Sustainable Development Goals. I like to make fun of the Sustainable Development Goals because it's just like kind of a bunch of hot air. In terms of like, it's like, that's nice that you created these goals, but like, really? Like, is anybody going to do anything about this? But the truth is like, well, we should, so like one is like, we should like, it's just like, I make fun of them. Sorry, everybody. But like, it's just like the UN doesn't really have the ability to herd the cats that are nation states to get them to do stuff. Right. I think we've proved this has been demonstrated. And so, but the Sustainable Development Goals are like really good goals. So it's like, hey, we really want to ensure that everyone in the world has access to clean drinking water. And going back to your point, what do we need to do that? And it's like, it could be any number of different types of sensors, and we should have some sort of entity that is actually held accountable to like making the end result happen. And who knows what kind of sensors they're going to use. We don't need to say that like, I mean, and it might come into the case like we need something like GHDSat, and the community that's like driving at that specific goal can determine that.
Yeah, and they'll need dedicated satellites to do that, right? Like the whole shared satellites for all these different use cases. Like there's just not enough tasking capacity, and if the power is in time series, and you're like maybe lucky to get an image like every other month, like you really need a dedicated satellite for the purpose, I think.
Okay. I don't have strong opinions about this. I've kind of always like thought, there's likely latent capacity in the satellites that we do have up that people aren't, just people can't get access to, right? So like, huge fan of Common Space, for example. Like
Common Space, right? Is a great example.
Well, it's an example worth debating. I mean, we were fiscal sponsors of Common Space. I know Bill was listening in here. A glorious initiative. But I think there's still like plenty of debate to be had, which is like, does Common Space need its own satellite? Or like, is there actually just like a legal financial policy hack that could make existing sensors, actually useful for the humanitarian realm? It might be easier just to launch your own satellite at this point, which is why I'm glad they're trying to do it. But I think it's a worthwhile debate.
Yeah, my sense is that it is, and especially if you want full control over it, and if you want to revisit the same areas over and over again, like even for a disaster, right? Like we focus on imagery after there's some disaster, but like ideally you'd want to continue to look at that same area for some months afterwards to see about the recovery efforts, or like there's flooding, like how long does that take for the flood waters to recede? And so I just don't see how you could get that much data unless you're actually controlling the satellite and the ability to we look at the same areas over and over again. Same thing with like infrastructure, right? Like companies that own and operate global infrastructure, like it totally makes sense for them to just own their own satellites, and like these things are just pointing at the exact same areas day after day.
I wonder, this Munich Re, is Munich Re going to fly its own satellites soon? It seems like,
I mean, it's getting more and more cost effective, right? I mean, we're seeing companies like pivot towards, you know what, we're not actually going to sell pixels anymore. We're going to build satellites. And I think big companies, there's lots of countries in the world too. Like this seems like this is where the business is heading, is smaller, cheaper, purpose-built satellites.
Yeah. This is all right. We're in agreement. I mean, this is again what I was saying at this National Academies of Science thing last week. It's like, I would say, like, there were plenty of people that are like, oh no, only the government can do this. Everyone knows that. And I'm like, I don't think that's true. I think we're going to see more satellites being flown by more actors. Linda's chiming in on LinkedIn saying she agrees with the need for dedicated satellites, purpose built. And then, Bill's open for the debate. But I think I find this compelling. I want to get to, so Tim Bailey asked earlier about the issue about human. He said there's an issue about human inspection to validate interpretation. He says, I work in the forest wildfire resilience field where there's a stampede of new data products that are not great data products. So yeah, I mean, we're going back to the error rate issue and kind of like the issue of this is, he posted this a while ago when we were talking about models and accuracy and, making, actually like informing decision support systems. I'll also bring up, relevant to this, is that I think Bloomberg published a story that's been going around on LinkedIn this week about Zillow removing climate risk information from its listings. I think Zillow and Redfin, they used to show like flood risk and fire risk. This is data that comes from First Street Foundation, and they took it out. They took it off. And the issue being that like we increasingly are encountering decision support information that could be fire risk for your house, or for the house that you're thinking about deciding to buy. But it's coming from entities that people aren't sure whether or not they can trust them. And I think First Street, kudos to them, sort of demonstrably have produced models that are better than FEMA's models or like anything that the government's been able to produce. But still, like, validating that sort of information is difficult. And I think I'm perceiving a need for, I always say new data institutions. But like arbiters that can actually like help validate this stuff. Anyway, I'm over to you in case you want to go back there.
Yeah. So, I think Tim has a great idea for you can start another podcast called Not Great Data Products. What do you think? You can evaluate like really crappy data sets. Like this is the worst,
That should be like we should do special episodes every now and then. Just like,
not
just
great data.
Talk trash about.
Yeah. This is the worst. So yeah, I mean, I feel like I just keep on ranting.
Do it. That's the whole thing.
Like, I think we have a real problem with startup companies, especially, I don't know, maybe this is a worldwide problem. I mean, I see it, really prevalent in the US here. Startup companies doing really questionable science.
Yep.
And there's because they're at odds, right? Like the business model that they have is completely at odds with the scientists. I mean, I guess we've seen this in very high profile cases outside of the geospatial industry, but like we see it in the geospatial industry as well. And people making promises for things that really just aren't practical and over-promising and under-delivering. And so, I'm not surprised that Tim has come across a lot of really not great data products. I don't know about the source of those, but like I've seen that quite a bit.
Yeah.
It's just
constant. Well, I mean, look, it's constant. I mean, and I'll say, I mean, this is why I'm at Radiant Earth, right? And like why I left, it's not why I left Amazon. Like Amazon was great. Like I had a very good 8 years there. But but what I realized was like, oh no, we do need to have institutions that provide data, but that aren't owned by investors, right? So that don't have the same sort of like forever growth incentive, which is not to say, I should say, like, some of my best friends are investors, like, maybe that might not be true, but like, I have plenty of friends who are investors. They are funded by investors. I don't think investors have inherently malicious intent. What I would say is that, like, investor owned or governed companies that are united by, just the need to grow constantly, are not always going to be the best stewards of data. And I would say in almost all cases, like, they almost can't be. The pressure to enshittify is unavoidable. And then also the sort of the competitive need precludes them from being like truly open about their models and how they operate, right? It has to be secret sauce, which I think if you're saying, like, if you're going out there and saying, like, hey, we have the data that is going to be used to regulate the environment and the real estate market and like risks to like life on Earth, you need to be held to a higher standard than just be like, and it's good, trust us. It's our proprietary secret sauce. So
yeah, and we can bring that back to STAC actually now, because
bring it home.
Because a few years ago, well, there's been an effort with STAC coordinating with CIOS. So Matthias Moore has done a bunch of this work.
He does that under the umbrella of Radiant Earth. Yeah.
And so, and that's, so CIOS, which is an international committee of space agencies, has a thing called ARD, CIOS ARD, analysis ready data. And so Matthias has been doing work on like mapping their requirements for ARD back to STAC. And so when I was involved with this a bit some years ago, we were in the early days here, we were identifying, like, what fields really need to be included in this for them to get the ARD certification or whatever from CIOS. And I think the immediate problem that I saw was that you really need and require radiometric and geometric accuracy to be published in that metadata. And I don't think that there's a ton, I could be wrong, but I don't think there's a ton of commercial satellite companies that are really willing to do that.
Interesting. Because of the proprietary nature of what they
their
do.
Satellites suck for the most part, because like they're they're CubeSats. They're like they're low cost, cheap things. Now,
amazing.
Maybe I get a whole bunch of people mad at me, which somebody told me that means that you're doing something right recently. But I don't want to make a blanket statement about all of it. I love satellite companies, right? Like
some of my best friends are satellite.
Some of my best friends are satellite companies. But like the realistic assessment is that these are lower cost, cheaper satellites, and the radiometric accuracy is not going to be up to snuff compared to giant school bus size satellites like Landsat is.
Well, interesting. I mean, but this is a solvable problem. I think you're just highlighting the need that it needs to be solved, is that if we are talking about a future in which more people are deploying sensors, and we're having more low-cost sensors going up, a lot of those are going to be CubeSats, but again, I guess the requirements are going to be bespoke, in the case of every sensor, to determine, like, okay, does this meet our needs? I'm a reinsurer. I need to have control of my own satellite that I can task, but this is what I need. Interesting. Okay. I put in links in the chat to a blog post that Matthias wrote about the sort of the cloud native approach to doing this stuff. So, or to ARD, and shout out and thanks to NASA for funding us to be able to do that work with Matthias, because it's been great. Okay, well, we've covered a lot of ground here. I mean, I love talking to you. This has been secretly like this is one of the great things about doing this is that I don't know the last time I had like an hour and a half or so to just talk to you about stuff. So it's been a real treat for me. Is there anything else you want to mention? Oh, wait, we didn't talk about my white paper. Did you read my white paper?
I did. Yeah, okay. I did. I read it yesterday. So like, yeah, I mean, great alignment with a lot of things. So, yeah, there's one thing perhaps we could talk about this credibility issue because as I told you, you know, I wrote this blog post and afterwards a colleague of mine was like, well, there's something missing from this post in that it seems like there's something else that's required here that you didn't mention. And I think that thing it's this credibility issue. And what I mean by that is it's not like if some random person, this happens a lot, right? Like they create a really cool thing and then they go out there and they're like, hey, help me with this thing. I want to create a standard. Like they just might not get a whole lot of traction from that. And with STAC, we had some credibility because of Chris Holmes. Chris started it and he had a good reputation and he'd been involved with OSGeo. He knew a lot of people. Like he brought that credibility to it. And we see companies like you mentioned, the New York Times, right, with RSS.
Yep.
Or
that's right.
You know, Google and Meta, like they come out with standards, right, like all the time, because they have this credibility. They're not guerrilla standards, right? They don't actually build them in a community, but they have enough credibility and weight behind them that they can accomplish a similar thing, which is this is a standard. Use it, and people start using it.
Yeah. For some reason, I feel very compelled to share. I'll also put in the chat a link to "You Just Haven't Earned It Yet, Baby" by the Smiths. Morrissey at his finest, you know, just be like, look, like that it is a harsh truth that you will confront throughout your life, you know, when you're trying to do anything, is like you do need to earn that credibility, right? And so like, so my white paper is called Emergent Standards, and basically it's an exploration of how do standards emerge without an authority coming and saying like, thou shalt do this, right? Linda just commented on LinkedIn, H3 and Uber is another great example where it's like Uber clearly knows what they're doing, and H3 was obviously good, you know, you know, for what it does, and they opened that up, and it's great. And now, you know, we talk about H3 a lot. So it's this interesting, you know, it's all sweet spots. Like you can't. We have many examples of institutions that are powerful and have sway in a lot of ways, trying to decree standards that just don't work because they are not actually aligned with what practitioners want. And then so practitioners can come up with their own thing, but you still have to have a Chris Holmes in the group. You have to have somebody who has the convening power or the credibility or something to like actually get you to pay attention.
Yeah. Exactly.
And which is a drag because it's like, well, how do you do that? And I'm like, I actually don't know. Like it feels like a historical accident in cases like when stuff like that works out. And that's actually probably true. Most of history is a series of accidents. Yeah.
I think that's true. Right. There's been a lot of research into this. Like, you know, if you look at like, you're probably familiar with this more than I am. Like if you look at like the path of Bill Gates and like other folks, it's like that have become billionaires or founded big companies. Like it's a lot of being in the right place at the right time. It's a lot of happenstance. It's a lot of luck. It's not just because like he was brilliant and he just like did stuff and it was like, oh, that like if he lived in another time, if Bill Gates lived in another time or Elon lived in another time, right? Like they wouldn't be the billionaires they were today. Our whole life is pretty much dictated by luck.
Oh yeah. Actually, so one final like bit of self-promotion that I'm allowed to do here is the latest episode of Text on Text, my other podcast about literature. We talk about a short story called "Anxiety is the Dizziness of Freedom" by Ted Chiang, and which is basically like, it's awesome. It's totally relevant to what you just said, which was
okay. Cool.
It describes a device where you flip a switch and it creates a parallel universe that you can communicate with. So you can communicate with what's called like a paraself, like a parallel version of yourself. And it drives people crazy. Like, it just causes all sorts of issues for people, because like there's a guy who's like, he's like, oh, my parallel self has a girlfriend, and I don't. And I'm like, what's wrong with me? Like, it just because, it basically reveals to people that how much of their lives are very much out of their control. Anyway, that's we've gone very far afield, but to bring it back to the point of STAC and everything like that, and how the stuff is created, is like, you do just have to try to do this sort of stuff, and I think it's you got to try, and I think what STAC has demonstrated is that it is possible, and I do think that there are parts of this playbook that can be documented and repeated, but part of that includes like having, you said it before, building with the community and finding champions, and you have to do that on purpose.
Yeah. And even just being engaged with the community, even if you are building stuff internally, I do feel like the more that you are engaged with the community, the better that thing is going to be. So if you're working with STAC, even if it's like for internal use, come to the STAC community meetings, and let people know what you're up to, and like maybe you'll get some good feedback. It's definitely, you're going to be better off. I think you're going to be in a better position the more you work with a larger, diverse group of people.
Absolutely. Well, yeah. Where should we point people? We can send people to stackspec.org. Where you can learn everything you need to know. As far as getting involved in the community meetings, where do we point people to?
There's a Google group that should be. Is it on the web page? That I think
I'm like looking around. I'm noticing the StackSpec site is directing people to our discourse, which we don't support anymore.
Okay, yeah. So there's more things that we need to do. So yeah, we're trying to clean. So the STAC steering committee, we actually, I think, have a meeting in the next week. Maybe it's tomorrow. And we're trying to clean up some of these things.
All right. Well,
so
stay tuned then. Stackspec.org. Matt, you're easy to connect with on LinkedIn and stuff like that. Maybe I don't know. Like, you can join the Cloud Native Geospatial Forum. There's plenty of people in our Slack, but we do ask people to pay to join that. It's not a lot of money. But yeah, there are lots of places to get involved, but we'll stay tuned and look at stackspec.org and see what you can find there. All right. This has been awesome. Thanks, Matt, for coming on. I predict that we'll have you on again, because we'll be doing this forever. And thanks for everything you've done for the community.
Yeah, no, thanks for doing this, Jed. Yeah, no, it's been this has been fun. All right, I love to chat, so anytime.
All right. Well, happy holidays.
All right. You too. Bye.